Today we're going to prove unknown angles where we have to draw usually we have to draw some auxiliary lines. So we're going to look at some parallel line properties, and I think also the exterior angle theorem again. But we've done this before with numerical examples where we had to, if you look at this diagram, we have A, B, and C, D are parallel, and we want to prove that Z is going to be the sum of X and Y. So what we've done before, when you have this goofy diagram with the angle in the middle, is we've drawn an auxiliary line. So that's what we're going to do. We'll start off drawing our own line here, and I'm going to split angle Z into angle 1 and angle 2. So for our proof, we say we draw a line, and we can call that line EF if we want to. EF, which is parallel to AB. That also makes it parallel to CD. So we draw that line, and then again, just by construction, Z is equal to angle 1 plus angle 2, and we can just call that construction. There's also another postulate that we could use later called the partition postulate, but we'll just say construction today. So Z is angle 1 plus angle 2. So now when you look at this, we can equate X with angle 1. X is equal to angle 1, and Y is equal to angle 2 because they are corresponding angles. So here's what we say. Angle X is equal, actually this example drops the angles, so we'll just say X is equal to 1, Y is equal to 2, and here's why. If parallel lines are cut by a transversal, corresponding angles are equal. You have to write all that out. If parallel lines are cut by a transversal, corresponding angles are equal. Well, then it's just substitution. Since X is equal to 1 and Y is equal to 2, we have Z is equal to X plus Y. And that's the substitution property. So these proofs don't take very many steps. When you have parallel lines, look for alternate interior angles or corresponding angles, and then substitution. The next example has this M-looking shape here, and we have that AB and CD are parallel, and BC and DE are parallel. And we want to prove that the measure of angle ABC, so we can call that angle 1, is going to be equal to the measure of angle CDE. I'm going to call that angle 3, because in here it's going to be angle 2. And the question is, where are you going to draw an auxiliary segment? Well, if you look at this, you don't really need one. What you have to do is look at this in a couple of parts. If I have AB and CD and they're parallel, then if you look at that, the other line is the transversal. So instead of drawing an auxiliary segment, I just labeled these angles. And by alternate interior angles, 1 is going to be congruent to 2. And then if you jump up here, now we have parallel lines, and CD is the transversal, making 2 congruent to 3. So we don't have to draw any extra auxiliary lines, but we can say that the measure of angle 1 is equal to the measure of angle 2, and at the same time we can say the measure of angle 2 is equal to the measure of angle 3, because if parallel lines are cut by a transversal, alternate interior angles are equal. Alternate interior angles are equal. You have to write that whole thing out, okay? So you have 1 is congruent to 2, and 2 is congruent to 3, and then if two things are equal to the same thing, they're equal to each other. Or, just by substitution, we can say the measure of angle 1 is equal to the measure of angle 3. That's the substitution property. And that's all you have to do for that one. So that didn't take very many steps. So I'm going to skip down to this example 3, and then we'll do the other ones in class, the other one in class along with a couple more, because in 3 you do have to draw an auxiliary line. We want to prove that D is equal to the sum of A plus B plus C. We don't have a triangle here. We have some weird looking quadrilateral that we have to deal with. So what I'm going to do is create a triangle, a couple of triangles, by extending a line. So I'm going to extend DC. And I'm going to label this angle X. So we can extend CD. And we just call that construction or auxiliary line. Doesn't matter. We can do whatever we want. Okay. So now that we have this, we can do a couple of things here. We have angle D is now an exterior angle to this little triangle. So D is equal to the sum of A plus X. So D is equal to A plus X. And then if you look at it, X is an exterior angle. X is exterior to this triangle. So X is equal to B plus C. And look at what you have. What's my next step going to be? First I have to write the reason here. These are both the exterior angle theorem. And then think about what you have, and what is my next reason going to be to finish this up? Because I can now write that D is equal to A plus B plus C. So if you saw that and you said substitution property, you would be correct. So we're going to work on more of these in class because it just takes practice to understand what to do, and it's kind of tough to start off, but we'll keep working on it. And again, we're going to work on more of these in class.